Welcome to our Physics 101 class. So in today's lecture, I'll be talking about or concluding on where we stopped down, that was under mechanics. So in our previous class, we were able to derive the equations for motion, which are number one, v equals to u plus at, and also two, v squared is equal to u squared plus 2as. Three, we're able to derive s is equal to u plus v, all divided by 2 times t. And lastly, 4 as s is equal to ut plus 1 over 2 at squared. So during the evolution of motion and during the solving of our questions, these are the basic principles we are applying as subjects on the mechanics. Now that being said, we move on to the next phase, which is the laws of motion derived by Sir Isaac Newton. Now, in motion, we have three laws that are derived by this famous scientist. The first law being known as the law of inertia, the second law which stated the property of force, and the third law we talked about action and reaction. So starting out with the first law states that every body continues in a state of rest or uniform motion unless acted upon by external force. This states that everybody within the earth or within the earth continues in a random state, in a linear state of motion if it is being acted upon by an external force. Example is the tendency of a passenger in a vehicle to tend to move forward when the brake is applied. That is exactly what we call inertia. Inertia is the ability of the body to resist change. So the law of inertia is also Newton's first law of motion. So Newton's first law of motion just talks about the ability of the body to resist change or to continue in a state of rest or uniform motion unless an external force is being applied to that body or to that system. So that's that for the first law. Now for the second law of motion. The second law of motion just states that the force is directly proportional to the change of momentum mv minus mu over t, which is the rate of change of momentum. And I stated earlier that momentum p is denoted as well the product of the mass times the velocity. So for a body to have a larger momentum, it has to have either a larger mass or a larger volume. A larger velocity. So if I say a large lorry moving with a speed of about, let's say, 70 kilometers per hour, 70 kilometers per hour, and has a total mass of 2,000 kilograms. It has more momentum than a smaller vehicle moving at 100 kilometers per hour with mass of, let's say, 700 kilograms. Because if we carry out the multiplication of this in order to get our momentum, we will realize that this particular body possesses more momentum due to the larger mass compared to this one which possesses a smaller mass. So we can see that momentum has dependency on the mass of the particular body of the system and the velocity at which that particular body is propagating. Now back to Newton's second law of motion. It says that the applied force is directly proportional to the rate of change of momentum of that particular body, in which we say that F is directly proportional to M, which is common for both. We put in our V minus U, all divided by T. Now, if we take note of the equation of motion I stated earlier, we can see that the first one says that V is equivalent to U plus AT. Now, let's try to make A the subject of formula. We take U over to this side, it becomes V minus U is equivalent to AT. Dividing both sides by T, divided by T, we get A is equal to V minus U over T. Now, this can be seen here. And in that essence, we can say that F is directly proportional to m times our acceleration, a. Now, in order to get rid of this constant of proportionality, we have to introduce a constant. Let's call that constant k. We can then say F is equivalent to k ma rather. Now, we can also say this our constant k is equivalent to 1. Therefore, we can say F is equal to ma. So this is a relationship, or this is the existence for Newton's second law of motion. Now, for the final law of motion, the third law of motion, a very simple one, which talks about action and reaction, like I've stated earlier. It states that for every action, there's an equal and opposite reaction. If I carry out an action, I'm bound to get an opposite reaction. An example is you fire your gun. If you fire a gun, it ejects a bullet in this form, which is the action. The jerking back of the gun is the reaction. That's a simple proportion. If you check the working principle of a rocket sent into space for all these extraterrestrial missions, you can see that it works based on the principle of Newton's third law, which says that for every action, which is the motion of the rocket, there is an equal and opposite reaction, which is the expulsion of hot gases from the engine. So this is the working principle of Newton's third law of motion. And that brings us to the end of Newton's law of motion. The first law stating that every body continues in a state of rest or uniform motion in a straight line unless acted upon an external force. The second law stating that the rate of change of momentum of a particular body is directly proportional to the applied force and it takes place in the motion of that force. Now, the third law states that for every action, there is an equal and opposite reaction. This brings us to the end of today's lesson under equation of motion. Now, in our next class, we will do well to talk about planetary motion, Kepler's law of planetary motion, gravitational constant, force of attraction and repulsion of planets, and all. So this brings us, like I've stated earlier, to the end of today's class. Thank you for watching, and please do well to hit the like button and be sure to subscribe to get more updates on this tutorial. Thank you very much. Have a nice day.